All right, so hello, grade 9 and grade 11s. So grade 11s, I must apologize because I haven't as of yet posted the video of the live lesson that I did yesterday on independent events. And the reason is because key data is quite the thing, guys. It's not... Yeah. You guys might think I'm rolling very nicely here, but I'll tell you this one thing: it's not as easy as I would make it out to be. So, because it's downloading the video from TikTok, then uploading it onto YouTube. Yeah, it's quite a bit of data to do that. It's not just like that, so apologies for that. Okay, but yeah, so today we are actually going to look at corrections related to the questions that we did, or the questions that I had posted and which I had asked that we would do. Okay, we're going to answer these questions and we're going to take it one at a time, so that we can have a clarity of understanding when it comes to independent events. Okay, so the first question says a die is rolled and a coin is flipped. Okay, now I hope we understand, guys. A die is what? Is rolled and a coin is flipped. And I think the first thing that I want to ask is that if we look at these two events, a die being rolled and a coin being flipped, are these two things independent or not independent events? Are they independent events, rolling a die and flipping a coin? Does the outcome of one affect the other? Okay, or let me say the probability of one, does it affect the other? Does one event affect the other event? Or are they independent? That's the question. Okay, I repeat, a die is rolled and a coin is flipped, right? Okay, so let me just go back to what we covered yesterday so that we can get the concept covered. It's very important. We said that two events are independent. Okay, two events are what? Are independent if the probability of one event is not influenced, and this was a key word, the word influenced. If the probability of one event is not influenced by whether the other event happens or not. Okay, that's how we know that events are independent. And then we even said that an example we can give is if a person is chosen randomly from a population. A is the event that the person's birthday is in August, and B is the event that the person is male. You can see, guys, that the probability of one event does not influence the other event. Okay, so that's why we say it's independent, and therefore we wrote down a formula that basically then, or a rule that applies whenever events are independent, and that is P, A, and B is equal to the product of the probability of A with the probability of B. So that's what we actually explained yesterday when we were speaking about independent events. All right, we then did a few calculations as examples, and then we incorporated the use of the addition rule and other rules, so that we can be able to then explore the different types of events and the application of the different rules in these particular problems. So we're going to look at this problem here. Okay, yes, this is grade 11. For those who are asking what grade this is, grade 11, we are grade 11ing it everywhere. Okay, so we have a problem here, and the question says a die is rolled and a coin is flipped. Okay, and I was asking, a die being rolled and a coin being flipped. If we look at these two events, the event of rolling a die and the event of flipping a coin, are these two events independent? Okay, or are they not independent? Okay, that is the question. And you can think about that whilst we explore the question. Or the die is rolled and the coin is flipped. Okay, yes, thank you, Mulal. The die is rolled and the coin is flipped, and they are asking what is the probability that the die will land on a 6 and the coin will land on heads. What is the probability that die will land on a 6? The probability that a die will land on 6. So let's look at the respective probabilities first. The probability that the die will land on 6. So the probability of getting 6 is that particular, the favorable outcome is getting a 6. Getting a 6, how many, what's the number of 6s we have on a die over the 20 outcomes in total? Okay, so the number of 6s first and foremost in a die is, we just have 1. And the number of total possible outcomes from a die is, how many possible outcomes do we have from a die? We have 6. So the probability of getting a 6 is 1 over 6. Okay, and the other one was flipping a coin. The probability that the coin will land on heads, the probability of heads, okay, is equal to the number of heads that we have. So in other words, the favorable outcome being heads, how many in a coin, the heads that we have, how many are there? There's only 1 over the number of total possible outcomes. Okay, so the number of outcomes that a coin possesses. Okay, so that they basically means the number of heads is 1 over what? Over 2. That's the probability of H. Now they are asking here, what is the probability that the die will land on a 6 and the coin will land on heads? So since we all then understand that the probability of A and B is equal to the probability of A times the probability of B, we also understand that the probability of 6 and H, in other words, we understand that the two events are independent, therefore we look at their product, which is what? The probability of 6 is 1 over 6. The probability of heads is 1 over 2. And therefore, 1 over 6 times 1 over 2 gives us 1 over 12. So the question was, what is the probability that the die will land on 6 and the coin will what? Will land on heads? What is the probability? So we take the we look at, we first were able to see that the two events are obviously what? Independent. Because rolling a die and flipping a coin are not events that influence each other. Okay, the probability of one event will not directly influence the probability of the other. So therefore those events are independent. So I had to first find the probability of getting a 6, which is 1 over 6. The probability of heads, which is 1 over 2. And then understanding that these two events are independent, I can then use or apply the rule that applies to independent events, which is what exactly? That the probability of event A, which in other words, the probability of getting a 6, that could be my event A, and the probability times the probability of event B, which is the probability of getting a head, which is 1 over 2. I multiply those two because they are independent events, I get 1 over 12. So the probability of getting a 6 and getting ahead is actually 1 over 12, which makes perfect sense. Makes perfect sense. 1 over 12. Okay, so that is my first question and its accompanying answer, how we get to the answer. Okay, thank you, Mr. N. So that is 1, getting the probability of 6. Part 2, getting the probability of getting ahead. And because I perceive that these are 2 independent events, I then apply the rule that applies to independent events. So this is generally the formula, but then I'm being specific about the probability of event A, which is the probability of getting a 6, the probability of B, which is the probability of getting ahead, and then I am multiplying, okay, the probability of getting a 6 and the probability of getting ahead, which gives me 1 over 12. So therefore, my final answer, what is the probability that the die will land on a 6 and the coin will land on heads? It's 1 over 12. Full stop. Let's look at the second question, B. Given 2 independent events, A and B. Let's read again. Given 2 independent events, we are told that the events are what? Independent. Given 2 independent events, A and B, such that probability of A is equal to 0.6, probability of B is equal to 0.5. Determine the probability of A and B. So what are we given? The probability of A, which is what? 0.6. And what else? The probability of B, which is 0.5. And we are told that the 2 A and B are independent. They are independent. We are told that they are. A and B are what? Independent. The first question says, find or determine the probability of A and B. Okay. So, first and foremost, we are told that the probability, A and B are independent events. The probability of A is 0.6, the probability of B is 0.5. And we are asked to find the probability of A and B. Mr. Trilon A, that is a false narrative there. Probability was never our friends. That's not true. If you choose, you have a choice. If you choose for something to not be your friend, just like when you have a company of people, if you choose for those people to not be your friends, then they will never be your friends. If you have an attitude of such a nature towards those people, then that attitude will basically be the one that dictates many of your interactions with those particular people, unless you decide to change that attitude. So thanks but no thanks. We don't embrace your thing. No, that's not true. That's also not true. That's something you've accepted. That's your own narrative. You've accepted it, and it will basically continue to govern your life for as long as you believe it. You know, we are what we believe, my friend. We are what we believe. So there's nothing that stops you from understanding class examples, and then moving from class examples you can go and actually attempt exam type questions, and then from understanding exam type questions and actually practicing those exam type questions, coming out of there and feeling like, you know what, I have a very good grasp, conceptual understanding of the probability, application, good grasp of the application of probability in class examples, homework examples, and the activities in the textbook, and then I have a good grasp and application of the same probability questions when it comes to exam questions, because I've practiced those sufficiently, and that should solidify the topic for you. So if you choose it, then it can get better. If you don't, then it will stay that way. It's up to you, man. You choose the narrative. So let's see, guys. Now, please, guys, you are welcome to, you can click there, you can invite to be a guest, so that I can interact with you guys and you can let me know what you guys think. We want the probability of A and B. How do we move from this? We are told A and B are independent events. We are given the probability of A is equal to 0.6. The probability of B is 0.5. We want to know what is the probability of A and B. So how do I proceed? Okay, let me not just give people the way. Let's see, what do you guys think? What are your thoughts? Okay, probability of A is equal to 0.6 and the probability of B is 0.5. We need the probability of A and B, understanding of course that A and B are what? Independent events. What do we do? A penny for your thoughts. Any thoughts? Any thoughts arising? Okay. All right. So let me help out here. So A and B are independent. If A and B are independent and I'm given the probability of A, which is that, the probability of B, which is that, I want the probability of A and B. Remember, there's a rule about independent events, and that is the probability of A and B. Okay. The probability of A and B is equal to the probability of A times the probability of B. The probability of A and B is equal to the probability of A times the probability of B. Why can I write this? It's because we are told that A and B are independent events. And remember, for independent events, this is a rule that applies for independent events. I have the probability of A. I can substitute 0.6 where the probability of A is given. Then the probability of B, I also have that. So I can substitute it into the formula where probability of B is. And then let us multiply 0.6 times 0.5. What is the probability of A and B therefore? The answer, the beautiful sweet answer, is equal to 0, yes, 0, Thank you, Mulalo. Thank you. So its answer is 0.3. Okay. Yeah. So I repeat once more. We were told that A and B are independent events, and then we were given the probability of A, and we're given the probability of B. So if these are independent events, we know that if we want to find the probability of A and B for independent events, very important, for independent events, we can apply the following rule. The probability of A and B is equal to the probability of A times the probability of B. That then allows you to substitute in the place of the probability of A 0.6 times the probability of B, which is 0.5. Then when you multiply the two, you get 0.3. The product is equal to the probability of the intersection of the two events. Okay, and that's the answer. Number 2, for the same question, was asking for us to find the probability of A or B. How do we find the probability of A or B? Probability of A or B. Okay, so the probability of A or B, what are we going to use here, guys? Okay, because remember, we have the probability of A, we have the probability of B, and now we've just recently found the probability of A and B. So if we want the probability of A or B, what can we use to find the probability of A or B? Because we have the probability of A, we have the probability of B, and we have the probability now of A and B, which is 0.3. So how do we find the probability of A or B? What can we use to find the probability of A or B? In our formula sheet, we have this formula, which we call the addition rule for probability, which simply states, and I love that Excellent in the comment section has just assisted us in being able to actually write down. There we are. Good, Excellent. Nice, nice, nice. I want to pin that comment there for everyone to see. Nice. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So in our formula sheet, in any question paper, this formula is there. It's called the addition rule of probability. That's very, very important. And whenever we want to find the probability of A or B, all right, and we have the probability of A, we have the probability of B, we have the probability of A and B, then we can actually go ahead and utilize this formula. So that means we can now substitute probability of A, that's 0.6. Probability of B, that is 0.5. And lastly, the probability of A and B, which is 0.3. So then we can solve this. 0.6 plus 0.5 minus 0.3. And what do we get? What do we get for the probability of A or B? Yes, Sipho. Maqhazima. 0.8. 0.8. 0.8. Nice. 0.8, as beautiful as it can be. That is it. That's all, folks. Okay, nicely done. Thank you, Zip. Very well done. Very well done. Very astute, very precise, very to the point. That's it. Okay. All right. So guys, please, whenever you are given, these questions, whenever you are given two independent events, all right, such that, as it says, probability of A is equal to 0.6, probability of B is 0.5, and they're asking you to determine P, A, and B. Remember, for independent events, the formula that applies for independent events is the probability of A and B being equal to the product of the probability of one event with the probability of the other. Okay, so this for independent events, this formula applies for independent events. Given that you have the probability of A and the probability of B, you can always find the probability of A and B. Or you could be given the probability of A and B and given the probability of A, and they ask you to find the probability of B. Or you can be given another and this one, and then they want you to find that one. All right. So as long as the events are independent, you can always write this formula and then write your substitution and then solve for the unknown that you want. All right. Then, of course, the second follow-up question was that they wanted the probability of A or B. Okay, so the other formula that's very useful is this formula that we refer to as the addition rule. All right, okay, this is the formula that literally is at the foundation of probability. Okay, guys, these are rules. We you know, when I was doing the grade 10, I introduced the general rules of probability, and this here was that addition rule that I was speaking about, the addition rule of probability. Okay, we also have the complementary rule, which is also helpful sometimes, because sometimes we are not given the probability of A, but we are given the probability of not A. So this complementary rule, if we are given the probability of not A, we can always find the probability of A by simply writing down this formula, substituting P not A if it's P not A that we are given, subtracting that from 1, and then getting the probability of A. Or it could be that we are given P not B, and therefore we can find PB by basically subtracting from 1 P not B and getting PB. Okay. So these are the rules that are important. The addition rule of probability, okay, which is this rule, okay, which I think by now you kind of see that it's important. The complementary rule is also important, okay, because oftentimes we are given the complement of a particular event, all right, and therefore we can use this rule to basically find the event, the probability of the event, not the complement of the particular event. And then, of course, now we are being exposed to what I call the independent rule, okay, the rule that we apply for independent events. So it's this: PA and B is equal to PA times PB. So these are the useful rules that we can utilize whenever we are solving problems of this nature. So let's look at another question. Two events, A and B, are independent. So once again, we are being told that the two events are independent. So immediately we're like, if the events are independent, if we have the probability of A and if we have the probability of B, then you know what we can do? What we can do is that we can actually find the what? We can go ahead and actually find, using the rule that applies to independent events. If we have the probability of A and the probability of B, we can find something. All right, so let's look at the question though. It says two events, A and B, okay, given two independent events, A and B, such that probability of A, which is 0,6, the probability of B is 0,5. Okay, oh sorry, we're doing that again. Sorry, I'm redating the question. Let's do this one. Sorry. Two events, A and B, are independent. All right, and it says the probability of A is 0,3. Okay, two events, A and B, are independent. The probability of A is 0,3. P not B is equal to 0,4. Okay, I repeat. Two events, A and B, are independent. The probability of A is 0,3. The probability of not B is 0,4. Now they are saying determine P, A, or B. Right? Okay, any thoughts as to what we can do here? Two events, A and B, are independent. Probability of A is 0,3. Probability of not B is 0,4. Now we are being asked to determine probability of A or B. So obviously the probability of A or B is used, or we actually can find the probability of A or B if for the addition rule we have probability of A, which is we have, this is P not B. We don't want P not B, we want PB. In other words, the probability of B. So we need to somehow change this, get P probability of B from P not B. Okay, And already in my head, I'm thinking there's a rule we can use to find the probability of what? Of B. And then even from that, after finding that probability of B, we can then find P, A, and B. Okay, using the rule for when events are independent. And then we can go ahead and find the probability of A or B. Okay, so there's quite a bit here that we need to do. But at the end of the day, statement says two events A and B are independent. And if two events are independent, and we are told that the probability of A is 0,3, and the probability of not B is 0,4, we need to determine the probability of A or B. Then it means that we can actually take steps towards finding that. So here we are, probability of A is 0,3. The probability of B, we are going to say probability of B is 1 minus P not B. So here, what am I doing? I am using the complementary rule. Okay, I am using the complementary rule. And I've just spoken not so long ago about the complementary rule because I have P not B. I want PB. So let's find PB. Okay. Because we're going to be one step closer if we can find PB. So we say 1 minus, what's P not B? P not B is 0,4. So let's subtract 1 minus 0,4. And that gives us 0,6. That is the probability of B. So we have the probability of A now. Obviously, we had it in the beginning. And now we've just found the probability of B. Okay, so two things. We have the probability of A, which is 0,3. The probability of B, we've now just found it's 0,6. Okay. And what's nice is that the probability of A is 0,3. The probability of B is 0,6. So we were told that the two events are what? Independent. So since for independent events, what do we know? We know that the probability of A and B is equal to the product of the probability of A with the probability of B. So that gives us a chance now to find the probability of A and B. So probability of A, 0,3. Probability of B, 0,6. We multiply the two. Let me wait and see what do we get, guys, when we multiply these two for independent events. When we multiply these two, Makwazima Sisibo is like on the money there. Eh? Okay, Sisibo, spot on. Spot on. Spot on. Sisibo is like 0,18. Okay. 0,18. I hope I can give, or at least people are feeling like, okay, we can see that it is 0,18. But what is that? It's the probability of A and B. So let's just go back again. What have I done? The question says two events A and B are independent. The probability of A is 0,3. There is the probability of A is 0,3. The probability of not B is 0,4. Hold on. This is the probability of not B. I don't want the probability of not B if I'm going to be finding the probability of A or B. I want the probability of B. So what do I use? The complementary rule. So I say the probability of B is equal to 1 minus P not B. Why? Because I want the probability of B. So the complementary rule helps me out here. 1 minus 0,4 there gives me a probability of B, which is 0,6. I am one step closer to getting to the answer of P, A, or B. I need one more thing. I have you, I have you, I need you. I need you. So for independent events, because I have you and I have you, now I can multiply you guys so that I can get the probability of A and B, U, 0.18. Now I can go to the addition rule finally. Addition rule can be used. So I've just used 3 rules in one question. I used the complementary rule at the beginning to get the probability of B because I had P not B. So complementary rule is very useful when I have P not of something. Independent events, if the events are independent, it means this rule can be used. All right, so I get P, A, and B, which is 0.18 as a result. Now, the grand finale, the addition rule of probability. Probability of A plus the probability of B minus the probability of A and B. This is the rule. Let us substitute, and then you tell me what's the answer. Probability of A is what? 0.3. Probability of B, 0.6. Probability of A and B, that's equal to 0.18. What is the answer, my beautiful people? Sisipa, you're too fast for my own good, man. Guys, you need to follow Sisipo. Sisipo has like 2 followers. Sisipo 142. Sisipo has 2 followers. I'm sure by the time we are done with this live, we can get it to above 10 followers. So if all 14 of the people that have joined in my live can actually follow Sisipo Matkwazima, I'm gonna just what is it? I'm gonna pin, but not pin, sorry. Pin her comment, the answer. Is it pinnable? Oh yeah, it is pinnable. That's Sisipo Matkwazima. Got the nice click there with the Kosa Matkwazima. So the answer there is 0.72. Thank you, Sisipo. Thank you so much. 0.72. Okay. That's a game. Let's enjoy. Let's play. Level up, level up. Level up. Aye, man, it's the holidays. Why are you doing maths? Aye. It's the holiday. Why are you asking me questions? I can do what I want during the holidays. Andy Timos, you are deciding to do what you want. No one is asking you why you doing what you want. So I'm deciding to do maths during the holiday. Let me be, please. Thank you so much. All right. Now I need you guys to do these for me. This question is saying determine with full motivation whether or not the events X and Y are independent in each case. You need to determine whether these are independent in each case. Okay. So I'll do the first one, but the next 3, if you want to do, or if you want to lead us in doing that particular one, please, you can invite, send me an invite. I'll have you as a guest and you can talk us through how to do number 2, 3, and 4. Okay. Yeah, I think let's get it interactive now. I think let's shy away from me being the one who's dominant here, okay? So that, yeah, we can be fine. So remember, this is a grade 11 probability, independent events specifically. All right, and I'm gonna lead you in the first one. So the first one says determine with full motivation whether or not the events X and Y are independent in each case. So case number 1, we have the Px is equal to 0.8, Py is the probability of y is equal to 0.5, and p x and y is equal to 0.6. And what we want to do is we want to determine whether or not the events in each of the following cases are independent. Okay, so let's come here. So we know for independent events, if we can prove that this left-hand side, px and y, and the right-hand side, px times py, if when we solve these independently we get the same answer, then we can conclude and say px and y is equal to the product of the probability of x with the probability of y, because that would prove that the events are independent, and that would be full motivation for that. So what we are going to do is we are going to check px and y. What's px and y? We are already told what px and y is. It is equal to 0.6. Okay, now the right hand side, the product of p, probability of x, with probability of y. Let's check if that gives us 0.6 as well. So the probability of x times the probability of what? Of y. What's the probability of x? It's 0.8. What's the probability of y? It is 0.5. What's the multiplication of these two? What answer do we get from the multiplication of 0.8 times 0.5? Yeah, Sisipo is not playing there, you know. Sisipo is not playing. Guys, we still haven't extended followers to... Oh, Sisipo has a private account. Okay, no, that's fine. All right, I think that's fine. Maybe she doesn't want those followers after all. She's content. Okay. So the probability of x and y is 0.6, whereas the probability of x times the probability of y gives us 0.4. So I'm sure you guys can see that the probability of x and y with the product of the probability, those are not equal. Remember, px and y is represented by 0.6, which would be on the left. 0.6 is not equal to 0.4, right? Therefore, the events x and y are not independent. Full stop. Therefore, the events x and y are not independent. So that's what they mean. We need to do full motivation. All right. Remember, if this left-hand side, the intersection of x and y, the probability of that, with the product of the probability of x and with the probability of y, if those values that I had gotten were equal, I would have then said px and y is equal to px times py. Therefore, the events x and y are independent. But because the values are not the same, I have to conclude and say they are not independent. Okay, I hope we are following this together. Any questions from anyone in the live session about what I've just done? Okay, they are not independent, we say in words. Any questions? Clear? Okay, it seems like it's clear. Right. Very. Okay. let's come here then. Then please do number 2 for me. And when you are done, you can guest request there in the comment section. Or sorry, you can just guest request. I will invite you in and you can speak about it. I don't know, Mulalo, how many marks it would carry. You guys, people want to know about marks. I don't know, Mulalo. I really don't know. Alright, I'm sorry. I don't claim to know everything. So I don't know. Yo, I'm still writing exams. Haibo, Mix, what do you mean you're still writing exams? What part of the world are you in? If you're still writing exams, does that mean schools have not closed for you? What's happening? Not closed for you? What's happening? Okay, so we're busy with this one. Determine with full motivation whether or not events X and Y are independent in each of the following cases. So I was asking you guys to do number 2 for me. If you're done with number 2, please go to number 3. If you're done number 3, go to number 4. But the minute you are done with 2 and you would like to actually lead us and guide us as to how you got to the answer, I'd be happy to have you as a guest, and you can come and talk to us about how you went about getting to the answer. Let's have people shine. I'm just shocked by what mixes pie typing in the comment section. He's still writing exams. Maths is tomorrow. What? I thought all schools have closed, or have some schools that literally, some schools are still writing exams. But some schools affected by strikes during the test exam season. Because I know some provinces were affected. Okay, please, I'm going to give you 5 or 10 additional, actually 10 minutes. So at 10 past 11, if anyone wants to request join so that you can lead us through as to what they did, I'll be happy to have you. Okay, are you done? Is there someone who can lead us there with the second question? Determine the full motivation whether or not the events x and y are independent in the following cases. Probability of x is equal to 0,2, probability of y is 0,3, and probability of x or y is equal to 0,44. Determine whether or not the events are independent in the following cases. Any thoughts? Penny for your thoughts? Okay. Okay, anyone who's willing to lead us along, guys, with the second one? P probability of x is equal to 0,2, probability of y is equal to 0,3, probability of x or y is equal to 0,44. We want to prove whether the events are independent or not. Anyone want to guess, request, and lead us along? Anyone? Okay, so we are given there the probability of what? Of x. It's 0,2. Then the probability of y is also given to us. It's 0,3. That means if I look at the formula for independent events, the right hand side I can actually find the product of p probability of x with the probability of y. I can do that, right? Because I can check the product, what is the answer. So that means 0,2 times 0,3, 0,2 times 0,3, what do I get? Probability of x is equal to 0,2. Probability of y is 0,3. When you multiply the two, guys, what do you get? Is it 0,06? Are we sure about that? 0,06. Okay, seems like people are in agreement. That's 0,2 times 0,3 gives us 0,06. Okay, then from the statement, okay, we are given px or y. But of course, what we want is px and y, because that's our left-hand side. So our right-hand side, which is like px times probability of x times the probability of y, we got 0.06. Now we want the probability of A and B. But in order to do that, it seems like we are going to have to use the addition rule. Why are we going to use the addition rule? It's because the probability of A or B has been given to us. Okay, but in this situation, we are going to be specific to the letters, the probability of X or Y. That's given to us. What is it equal to? The probability of X or Y. It's 0.8. 0.44. 0.44. That's going to be equal to the probability of X, which is 0.2, plus the probability of B, which is 0.06. That's if what you guys have said is actually really true. That's 0.2 times 0.3 is 0.06. Okay, minus probability of X plus the probability of Y minus the probability of X and Y. So that's minus the probability of X and Y. So we're going to solve for Px and Y. So let us solve minus 0.2 minus 0.06, which is equal to negative Px and Y. So let's add here, subtract. Okay, I believe it has 8 somewhere. Okay, what do we get there? 0.44 minus 0.2 minus 0.06. 0.18